Yeah. So what is up? Let's see. Okay, I gotta set it up. So I run Tmux. In case, uh, I guess if you've been wondering how I've been splitting my console uh, and doing things like that, moving around. Yeah, maybe a little bit of a setup. So I use Tmux and I use Vim inside Tmux. And yeah, we just got a couple of things set up. So there's this thing called cddir, I think. Something like that. CD path? CD path, right. And if you have that set up, then it works like a path, but it basically means if I go cd something like this, then it will look in all of these places, including the current folder, to find it. And so that's how I can get into that folder real quick. You'll notice it's go slash home go source github.com. This file structure is based on Go, the way it does, the way it works there. And so I had that set up and I just never got rid of it. So that's how I store all my projects. Vim, yeah. Hey Blue Ghost, welcome back. Yeah, Vim's not too hard to learn, really. Like I think the thing with Vim is the more you use it, the more you know how to use it. So like starting with just, I to switch to insert mode type stuff, escape to get out, like that's the first very basic thing. I have JK mapped to escape, and that's how I can get in and out of insert mode really quick. And then it's just about slowly learning things like D for delete, C for change. So for example, if I wanted to delete 5 lines, 5dd, starting with basic things, and eventually you learn more and more commands, right? Like you kind of learn them as you go, as you need them. For example, if I want to replace this word console with something else, I would use C for change, and then IW, which means the word that I'm currently in, which gets rid of it and puts me into insert mode, as you can see at the bottom of the screen. Then I can start typing straight away. Yeah. Slow and steady is how you learn Vim. All right, there was no input yesterday. There's a couple of I think like games. There's a website I think called Vim Adventures or something, where you're basically the cursor. And it teaches you all the commands, which is pretty cool. Yeah, this is the one I'm thinking of, but I shouldn't run it when I'm streaming. I'm afraid my computer's gonna crash. So that's one way to learn as well. But you learn a lot of like word movement commands, like W to move one word at a time, B to move backwards one word at a time, E to move to the end of a word one word at a time. And I don't really use those commands. If you watch my stream, you'll watch me hold down H and L a lot to move left and right. Anyway, looks like challenge is up in 8 seconds, so I'm gonna just go straight to it. Here we go. Whoa. Oh, that was close. I pressed the wrong thing. Oh, this is my puzzle input. Wow, okay. There's no link for it. So I catch the airport shuttle, and I'm going to try and book a new flight, but all the flights have been cancelled because of a storm. So while I'm on my flight, I decide to check in with the elves back in the North World, playing a memory game. In the game, the players take turns in saying numbers. They begin by taking turns reading from a list of starting numbers, which is my input, the ones I copied. The niche term consists of considering the most recent number. I guess I could chuck it in here. There's no harm in that. Cool. If that was the first time number has been spoken, the current player says 0, so it looks like I need a list of spoken numbers. Otherwise, the number that has spoken before, the current player announces how many turns apart that number is from when it was previously spoken. Okay, so this is a number to turn, I guess, which means we need a way to keep track of turns as well. So after the starting numbers, each turn results in that player speaking aloud either 0 if the number is new, or an age if the last number is spoken. For example, the starting number is 013, 036. Since that was the first time number is spoken, the fourth number spoken is 0. Next, since the last number of turns last time 0 was spoken, since it had been spoken before, the next number to speak is the difference between the number. So this is 3. 3 has been spoken, so now it's 3 again. 3 is now 1, 0, 4, 0. The game ends when elves get sick of playing or dinner is ready, whichever comes first. What is the 2020th number spoken in the example above? In the example above, it's 436. Well, that's quite straightforward, isn't it? So turn is starts off at input.length, right? So next, now I'm not going to put in a function. So the next number, we consider the last number spoken. Last number spoken is the length minus 1. We consider the latest it had been spoken. So last num, last turn is spoken last num. So we need to pre-populate spoken as well. Right? Yeah. So the current turn is input.length is the current turn. The current turn is always input.length. If last turn isn't null, then, so we have it, then next num is going to be the current turn, which is input.length, minus last turn. Otherwise, next num is 0. And then we add next num to next num. Okay, and the first number spoken, so we stop when input.length is that thing. Length is less than 2020. We do this. That seems quite straightforward. Console.log. This is an input.push. This is oh, it is input.push. Okay. Well, let's see what we get. Apparently my number is 0. That doesn't look right, and yeah, it's not right because I never update spoken. That seems a bit more right. That's definitely not right. Spoken should be the turn I last spoke this number, right? Ah, input.length plus 1. I need to walk through this, eh? So input is going to be 0, 3, 6 for the example. Fourth number, 6. Okay. So last number is 6. Last turn that 6 was spoken was 3. Ah, this needs to be I plus 1. So next num is 0. And so the last turn that 0 was spoken I'm going to do just 5 here. What's going on here? I'm getting my numbers wrong, eh? I'm quite tired today. Now consider the last number spoken. This should be a pretty straightforward question. Since that was the first time the number had been spoken, 6. So we consider 6. So we're on turn 4. Okay, we're on turn 4, right? Turn is input length plus 1. Okay, we're on turn 4. The last number we spoke was that, which is 6. Actually, no. 0, 3, 6. Yeah. So we're on turn 4. The last number that was spoken was 6. The last turn that 6 was spoken was So I don't pre-populate it then, do I? The last turn that 6 was spoken was nothing. And then now that I've used it, now the last turn that 6 was spoken was 3. So spoken a last num is input.length. Zero, and then turn 5. Now consider the last number spoken, 0. Yep. Since it had been spoken before, should we just make this like a n squared loop? I'm just making an n squared loop because this is breaking my brain for some reason. I don't know why. Last time is this. For let I equals input.length minus 2, I minus minus, I greater than equal to 0. Oops, wrong way around. See, look, that shows how tired I am. I can't even write a for loop properly at the moment. If input I equals last num, last turn equals I plus 1, I believe. Well, equals I, we can do I. Well, it's more correct to say I plus 1 with the indexing we have in here. So at this point, next num is 0 if last turn is not null. Next num is turn minus last turn. Input.push next num. Console log input. Okay. So I'm off by 1 somehow. But it's okay because they gave me all the inputs. 036033140. Yeah, so there's something wrong with my caching. I'm not sure what it was. So we want 2000, right? 2020, I mean. And then we want the last number. 436. 436, cool. And then we can check the rest of them. 132 is 1. 213 is 10. 312 is 1836. So given my starting numbers, the 2020th number is 1428. All right, let's go on. And so I just didn't do any smart, quote, smart stuff, like optimization stuff. All I'm doing is every time I have the list, I'm just going to take the last number and then starting from the number before the last number, just searching backwards until I find that number. And if I don't find it, then the next number is 0. If I find it, then the next number is whatever that difference is. And so the way, because I've implemented by searching through the list every time, this is now what's called a big O of n squared algorithm. So if it takes 10 time steps to run on an input of size 10, then to run on an input of size 20, it will take 4 times as long. It will take 40 time steps. And so you don't want to write algorithms like this, generally speaking. Right. And so this is why, right? Now we want the 30 millionth number, I think this is. Yeah. And if I had written it this way, the way that I'm writing it now, it's going to take a long time to finish. If I'm just going to put this in here, input.length mod, let's do every 100,000 numbers. I'm just going to log out what that number is so we can see it progress. Oh yeah, and you can see it takes a long time to do it this way. Because, yeah, if it took 1 second to get to 2,000, 30 million is 1.5 million bigger than, no, it was 15,000 times bigger than 2,000. I'm using a calculator, which means this algorithm will take 225 million times longer to run to get to 30 million. So that's not going to work, right? You can see that it's taking forever. So we can't go up to 30 million like this. We have to do that optimization that I was trying to implement before, where we want to keep track of the last turn for every number. But it's messing up because, why is it messing up? I know what I did wrong. I just have to not include the last number every time. So input.length -1. So I'm going to skip the last number. right? Const spoken is this. So spoken input I is I plus 1, I'm going to go with. And then I'm going to use the test input again, just to make sure I'm doing this right. I'll use 231 this time, which is 78. I should get 78. Oh, no, I can't do that. I need to use the actual, like, that input, so I know what all the numbers are. So spoken is going to be pre-populated now, with 0 being 1 and 3 being 2, right? So this is a map of number to last turn. But most importantly, we leave out the last one, right? So last number is going to be, so this is 6. So instead of looking for it, we're just going to ask spoken to see if it's in there. Let last turn equal that. And this is a const. Now, if last turn is null, it's not. If it is null, then next number is 0. If it isn't null, then it's turn minus last turn minus 1. And we push that number in. You're going to print out the whole input this time. Okay. Gonna need to do this time. 0360331. Ah, right, we need to update spoken with the current number, right? Not the next number, the current number. Spoken last num needs to be this turn. See, so we're on turn 4, but we're writing 6. So this is actually turn minus 1 that needs to go in here. 036033140. Yeah, I have all these +1 and -1s everywhere. I feel like I have an extra +1 or -1 somewhere. And that it can all be simplified, but I don't have the concentration right now to figure out which ones are necessary. So that seems to be good. So now we're gonna go over to my input and see if I get the same result as I had before. Yes. Now now I've eliminated that for loop in here, right? I had another for loop in here before. But now that I've eliminated it, this algorithm runs in linear time, big O of n. And so this should be relatively quick. I say relatively quick. Please don't let me down, computer. That's interesting. Some of them take a lot longer to run. It's like going fast and slow and fast and slow. But you can at least see that it's going faster. There's something wrong somewhere that's... Yeah, I'm not sure what's wrong. Maybe it's all these string conversions. I think because I'm using an object, all these numeric inputs get turned into strings when I use them as keys. Maybe if I use an array for spoken, it'll be a bit more happy. But I'm almost there, so I'm... Oh no, wait, no, this is 2 million. Okay, let me try this and see what happens. Ah, interesting. I wonder where that slowdown is. Because this input, this algorithm is pretty straightforward, right? It's just a straight up loop. I don't need to push into input. Once I have spoken, I don't need input anymore. Right? Turn equal length plus 1. That last num equals. So I don't need these two lines. Last turn is spoken last num. Next num is 0. Spoken last num is that. I don't need to push, but I do need to update some stuff. Turn plus plus. Last num equals next num. Maybe that would count as an optimization. There we go. All right, so it was the array allocation that was slowing it down. It looks like. Hello? Oh, input.length. Input.length. Right. Okay. I don't have input.length. While 10. But I don't trust my input anymore, so I'm just gonna check it again. 3. It's not 3, right? It wasn't 3. I'll turn less than or equal to. I feel like my algorithm's gone wrong now. Oh, this is not the test input, this way. 0360331046. Isn't that correct? 0360331046. Yeah. 0146, 0140. 4 hasn't been spoken. Ah, it would be null, right? Oh no, it is null. Oh, I was still printing out this. I should be printing out last num, right? Oh man, all these rookie mistakes today. I'm just not updating, like I'm not updating everything that I need to update in my algorithm. So yeah, so I've changed the algorithm from, instead of having to keep updating, maintaining that giant list, I'm only maintaining the last number and the last time each number was spoken. And because of that, because these are array lookups are linear time, I'm saving up on that for loop, which means it's constant time lookup now. And so yeah, this algorithm should increase in linearly in terms of how long it needs to execute it. But I'm still getting errors because this is not the correct answer. Is it? 58. It's not. It should be 436. Ah, I'm 1 off. Okay, so my turn my turn number is now yeah, my turn number is now 1 off by 1 because of all these, because of the way I restructured the algorithm. and I got that empirically. That's okay. Sometimes it's faster to do things empirically. Yeah, see, it's off by 1. Then 2020 is that. So yeah, I definitely have an off by 1 error in here somewhere. And that is something I would need to work out if I was doing this for real. 1428. Okay, so I'm pretty happy with that. It says with this, the number is the 30 millionth number is 175594, which it is, which means I'm happy to run it on my input and get 3 million something. I'm going to chuck that in. Oh, I closed my tab. Restore closed windows? Oops. Submit. Let's go. All right, yeah. Oh, that took ages. What was it? Yeah, 16,000. So this is another good little a good lesson on some programming fundamentals, right? First, I didn't pre-allocate my array at the start. Now JavaScript lets you not pre-allocate array, so it lets you write into any array value you want, right? I can go A is a blank empty array, A 2000 equals 1, and it will happily do that. It will do A is now 2000 empty items and then a 1. But internally, what it has to do is it has to pre-allocate that amount of, has to allocate that much memory. And while we'll happily do that, let's say I write into 2000 and then I write into 1 million. No, let's say I write into 1 million, like right off the bat, right? Then it now allocates those 1 million element. I'm guessing anyway that it will allocate that 1 million sized array. But then if I then tell it to write into index 2 million, now it has to allocate a new array that is size 2 million, and then it has to copy that first 1 million items over into that second array. Right? You can't just extend an array. The only way to extend an array is to copy it, duplicate it, is to allocate the bigger array and then copy all the elements over. And so by not pre-allocating the array, JavaScript has to keep copying all the elements of the array every time I allocate beyond the end. Now, a lot of programming languages don't let you do that, right? Like Java, C#, Python, etc. won't let you write off the end of the array. You'll get an out of bounds error, and that's one of those things between. Oh, I was going to say between static and dynamic languages, but that's not true. Python is dynamic, and it doesn't let you write off the end of an array. So it's really just language semantics, and the choice, I guess, behind the language creators of what to hide from the programmer and what not to hide from the programmer. In this case, JavaScript chose to hide the fact that it has to copy the array from the programmer. But what that leads to is the situation I ran into, which was I had this giant slowdown from all this copying that was happening behind the scenes that I wasn't aware of. And that's just a trade-off when it comes to language design. What else? Oh yeah, and then just that basic idea of an n-squared algorithm versus an n-squared algorithm, which is called a quadratic time algorithm, or a linear algorithm, which is big O of n. Just that's not. And so yeah, so I guess this challenge is a good challenge in terms of like optimization. If you're relatively new to programming, yeah, a lot of those things you probably won't run into in day-to-day programming. But when it comes to something specific like this, or you're writing some kind of server-side processing code, you might run into these memory or execution time sort of things that you should be aware of if you are or intend to be a professional programmer. So, cool little program puzzle. Yeah, I enjoyed it. And I guess I'll see you tomorrow. Thanks for joining me. So, cool little program, puzzle. Yeah, I enjoyed it. And I guess I'll see you tomorrow. Thanks for joining me.